guys, welcome to the last day of new material on the unit circle. Just a reminder that tomorrow on the 14th you'll have an assessment over all the stuff we've talked about in the unit circle. So you'll have a homework assignment that'll be due on Thursday, and then you'll have an assessment that's signed on Thursday due on the following Sunday. So if you have any questions, make sure you log on to Zoom and ask questions. So we're going to talk about unit circles. So as of today, on Monday, we talked about degrees and radians on the unit circle, provided a website for you to go to get more comfortable with it. Yesterday, we talked about the coordinates on the unit circle and kind of how they work, provided a different website to talk about matching those because you will have to memorize that. And so today what we're going to do is we are going to solve the 6 trig functions on the unit circle. So what you're going to want to do when you do this is you're going to have the unit circle with you, filled out the whole time, to constantly be referencing it. When you get to classes next year, you'll not be allowed to do the unit circle. You'll have to recall this from memory, but constantly having it with you the whole time. So by the end of the class period today, how can you use the unit circle to define the trigonometric functions of any angle? So there's also inverse finding trig functions. We're not doing that this year. We're only doing just evaluating regular trig functions. So here's a couple slides, and I'm actually going to show you both these because I think this slide right here gets a little bit confusing, but I wanted to show you both of them. So how to evaluate trig functions? Well, in the first quadrant, okay, sine and cosine and tangent and cosecant, secant, and cotangent are always positive. So when you're evaluating them, they're always going to be positive. In quadrant 2, sine and cosecant are positive, but cosine, secant, tangent, and cotangent are always negative. Then in quadrant 3, sine, cosine, cosecant, secant are negative, and tangent and cotangent are positive. And then in quadrant 4, sine, cosecant are negative, along with tangent and cotangent, and then cosine and secant are positive. Okay. I think that's a little bit confusing because when you're evaluating a trig function, you figure out which quadrant it is in. Is it going to be positive or negative? And then you find the measurement. What's an easier way to do that instead of having to remember those tricks like this for every single quadrant? Well, I think it's easier to remember this. If you remember, all students take calculus. So for the first quadrant, A, all, everything is positive. So everything is positive. All. Students, so S, so sine and cosecant are positive. Everything else is negative. All students take, so T's down here, tangent and cotangent are positive. And then the last one right here, take calculus. So calculus, so cosine and secant, positive. So instead of remembering up top what the part was of which quadrant's which right here, if you just remember the term, all students take calculus, all everything's positive, students, sine and cosecant, tangent, take, cotangent and tangent, calculus, cosine and secant are positive. If you just remember that, then you don't have to remember the plus or minus things. You just know what your final answer is going to be. So I think this slide right here is probably one of the most important slides of this entire talk today that you need to know about. So this is probably one of the most important slides. I would definitely write it down. I would take a picture of it. This slide, the unit circle, is what's going to help you through most of your trig next year. Okay? So let's start doing this because what does this mean? We're going to start pretty easy here. So we're going to start with evaluating something that's already on an axis. So it says, and I have the answer here, I'm going to do it to the side as well. It says evaluate the 6 trig functions at 270. So I look at my unit circle, okay, and at my unit circle, I know that I have the coordinate at 270, that is at 0, -1. Okay? So I know that my hypotenuse, because we're on the unit circle, my hypotenuse is always 1. And remember, I'm going to go up here to notes from yesterday. Whoop, whoop. Right here, these notes from yesterday are really important, that x goes with my adjacent and y goes with my opposite. X goes with my adjacent, y goes with my opposite. So I'm going to go back down to for today. So I know that x goes with my adjacent, so my adjacent is 0, and my opposite is -1. Okay, so my opposite is -1. Again, x, y. X comes before Y in the alphabet, and A comes before O in the alphabet. So that's how you remember adjacent, opposite. So let's get going. Let's do our Sohcahtoa, and let's start solving this. So Sohcahtoa. Again, you can memorize the other ones, but I like to stay consistent through everything. I think it makes my answers a little bit easier. So my sine of my angle, which is 270, or my given angle, is going to be, sine is opposite, which is -1 over 1, which is -1. So I'm going to do cosecant next, because that goes with sine. And all I'm going to do is flip it. So I get 1 over -1, which is -1. So sine and cosecant are both -1. Now I'm going to do cosine. Cosine is adjacent, 0, over my hypotenuse, which is 1, which is 0. Secant, I flip the fraction. So secant would be 1 over 0. You can't divide anything by 0, so that's going to be undefined. Okay. And then I go to my last one, my trig, my tangent. So tangent, my given angle, is opposite, -1, over adjacent. That also is going to be undefined. And then cotangent is adjacent over opposite, which is 0. So even though tangent is undefined, that does not necessarily mean that cotangent is going to be undefined. The same thing with cosine and secant. So when I would say to evaluate the 6 trig functions, if they're at an axis or not, this is what I would mean. Find your adjacent, find your opposite, find your hypotenuse. Your hypotenuse is always 1. And then just plug them in using our old friend Sohcahtoa. Okay. Hopefully you're okay with that. Again, you have your unit circle. You can hear mine's right here written out by me. And I'm using this up here. All students take calculus, which I'm going to use on the next problem. Okay. So let's keep pushing along. Okay. So what happens, because some of you guys are like, okay, great, love or check, but that's not always going to be the case. It's not always going to fall on an x or y axis. What happens next? Well, let's look at tangent of 240, of -240. So I have tangent of -240. So I'm going to look at my unit circle and say, okay, well, what's a coterminal angle of -240? So I'm going to take -240, add 360, and tangent of -240, this is the same thing as tangent of 120. Okay, so I go to 120 on my unit circle. So I go to 120 on my unit circle. And on my unit circle at 120, the point is -1/2, comma, √3 over 2. Here's my x, here's my y, or my adjacent and my opposite, and my h is always 1. So I go to -240, which is the same thing as tangent of 120, and there's my point. Okay, so the first thing you want to do is write your point down. Well, all students, so I know that tangent is going to be negative here, because 120 or -240 is in quadrant 2. And all students, only sine and cosecant are positive there. Okay? So now I go through and I start solving. So tangent is opposite over adjacent. And some of you are going to say, okay, this is a complex fraction. We've already done complex fractions before. So what that means is I keep the first, flip the second, and change the sign to multiplication. Stay, change, flip. Then if I can, I cross simplify. Well, this goes away with this and I get a -1. So tangent of -240 is -√3. I do not give out the decimal. I keep it in exact form with the square root there. So tangent of -240 is -√3. And that would be my answer. So that's what I do for every single one. Now, tangent, cosecant, secant, cotangent are going to involve a little more math. Sine and cosine, I'm going to look at the unit circle, identify what I need, and go from there. Okay? So let's do another one. Let's do cosecant, and then we'll do some of the ones down here as well. So cosecant of 17 pi over 6. Ugh. Okay. So I'm going to change my color real quick. So cosecant of 17 pi over 6. Well, that is the same thing as cosecant. I'm going to find a coterminal angle, so I'm going to do 17 minus 12, which is the same thing as cosecant of 5 pi over 6. So cosecant is the same thing as 5 pi over 6. Okay? So what I'm going to do is look at 5 pi over 6 on my unit circle. So I'm going to find it. I'm going to look at it, and 5 pi over 6 is -√3 over 2, comma, 1/2. Okay? Here's my x, here's my y, so here's my adjacent, here's my opposite, and my hypotenuse is always 1. So cosecant is the same thing as sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Okay? All students, this is in quadrant 2, right? So this is quadrant 2. So my answer is going to be all students, so it's going to be positive. So I know my final answer here is going to be positive because we're in quadrant 2, and sine and cosecant are always positive here. So let's get going. So I have 1 divided by, because hypotenuse is 1, opposite. Well, opposite is 1/2. So that's the same thing as 1 times 2 over 1, which is 2. So the cosecant of 5 pi over 6 is +2. Okay? Hopefully that's okay. Hopefully we're kind of understanding that. We're just plugging into what the trig functions are and then simplifying them down. Well, let's do a simpler one. Let's do cosine of 7 pi over 4. Okay? Because I just did some ones that are pretty complicated, so let's do this one right here. Cosine of 7 pi over 4. So I'm going to find 7 pi over 4 in my unit circle, and the coordinates for 7 pi over 4 is √2 over 2, comma, -√2 over 2. Here's my x, here's my y, here's my adjacent, here's my opposite, and my h is 1. Again, it's kind of overkill writing this out every single time, but hopefully it helps you. So cosine is adjacent and hypotenuse. So my adjacent is √2 over 2 over 1, which is just going to be, my answer is √2 over 2. Okay. Hopefully that helps you. Again, cosine and sine, you just look at it and say, really, what is my coordinate, x or y? Which one am I going with? And that's my answer. Cosecant, secant, tangent, and cotangent, you're going to have to do a little more division. But that's kind of how we evaluate without using a calculator. Everything will have to be exact here. I will not take decimals. Okay? And we're just going to finish up really quickly about tomorrow. Like I said, tomorrow you're going to have an assessment over unit circle, and that shouldn't say week 4, it should say week 5. My apologies. And that is going to be due on Sunday. Also be attention for the video for next week, the last week of school. I'm actually going to give you your final review. I'm going to assign that to you also on Thursday. And for all 10 questions you do on the final review, you can just submit them to me, email them, submit them through Schoology. I'm going to give you some extra credit. So if you have any questions, please log on to Zoom. If not, have a fantastic week. Thanks for stopping by, guys.